The neuropsychiatric thing, it's not their fault. IQ score is the right way to refer to this score, not neuropsychiatric score or neuropsychological score, which would be a little better. So here's another one, box plot. And you've all studied box and whiskers graphs in other classes, so I'm not going to go over what the median line is and so forth. You could also graph the full distributions with a histogram like this. So I did that here. And one of the interesting things about this is for some reason there's this, I mean, I'm sure it's just random, but there's this dip in the jaundiced group between 110 and 119. The non-jaundiced group has a nice bell-shaped curve. But it makes it hard to read this. So are there any questions about the main part of assignment 3? I think you all did pretty well on it. And then the extra credit part, what we wanted you to do was realize that the within subject standard deviation is 4 and the repeatability was 11. And the interpretation of that, which is that the 11 is that if you have the same subject and you have 2 different examiners assess IQ in that same subject, the difference between their scores will be 11 or less 95% of the time. So if you got that right, then I think you got a maximum of 2 extra credit points. Is that right, Carolyn? Okay. Now, none of you did this, but you could have tried a Bland-Altman plot like this. Now, to do that, you have to take 2 specific raters. So I took Satcher and Richmond, and the 2 of them, there were 142 children who were examined both by Satcher and Richmond. And then I graphed the difference between Satcher score minus Richmond's score versus the average of the 2 scores. And from this you can see that there's really almost no bias. I mean, Satcher was 0.49, basically half a point higher on average than Richmond, which is well within random variation. You can also see that there was no tendency of these differences to get larger as the average score increased. So this is not a question of measurement error proportional to the mean. And the limits of agreement go from here to here, minus 10 to plus 11, which makes sense considering the repeatability is 11, remember, and that meant that 95% of the time they're going to have a difference in the scores of about 11. Okay, that's assignment 3 review. Is there any questions about assignment 3? All right, now we can get to the loose ends. So the loose ends I want to talk about are basically field types, yes/no fields, blobs, field name. Then we can talk about field names and the idea of a front end versus a back end, and we can go over some on-screen data entry conventions, which will segue us into different on-screen data collection mechanisms, specifically web-based data collection. So yes/no fields. This was brought up by several people in the lab, and several of you learned that a yes/no field or a binary field isn't particularly useful because what you almost never want yes or no. You want yes, no, or unvalued. Okay, and that's not a binary field. That has 3 possible values: yes, no, and unvalued. There are occasionally times when yes, no makes sense. A little later we'll talk about check all that apply. And when you check all that apply, a yes, no field makes sense. Okay. Another one would be, have you obtained a consent form from this patient? Okay. That could be a true yes, no field. Okay. Because it's either yes or you haven't obtained a consent form from the patient, right? So there are times when checkboxes and true yes/no fields are fine. But most of the time, what I like to do for yes/no fields where I actually want the possibility of yes, no, and unvalued is I create a drop-down box like the one we created for race. So I am now going to try to demonstrate that by getting out of PowerPoint and going into a copy. Well, I need to launch the demo database, the one that you used. Okay. This is the one you used in lab, or very similar to the one you used in lab. It's not exactly, because you'll see that I actually changed Latino from a checkbox to a drop-down yes, no, and jaundice from a checkbox to a drop-down yes, no. Now, I didn't want to add this complication when we were doing it in lab, but that's why it's a loose end that I'm tying up right now. So you can see that, with Latino, you might, in fact, in this sample, we did know who was Latino and who wasn't. We knew yes or no on all of them. But it might be that you've got an unvalued thing on this, okay? And having a yes-no drop-down, it allows you to distinguish between unvalued yes and no. And the way this looks in the actual database is very similar. So I'm going now into the table, and if I go into the table and I go to Latino field, okay, you can see that it's a byte, which is a very short integer. That's what byte is. It's a very small integer. There's long integer, there's integer, and there's byte. Or in some databases, there's long integer, and tiny integer. And then there's, and then if I go to lookup, you'll remember this from the lab. It's a combo box based on a table or query, and the table is called LKP NY for no yes. And if you go to that table, LKP no yes, you see that no is 0 and yes is 1, which is standard for statistical packages. One of the advantages of this is if I took an average over this field in the whole database, I would get the proportion of Latino patients. If I average this field over all the records in the database. Okay, so that's yes, no.
Can we use the same lookup box for all the field,
Any other yes, no field, yeah.
You don't have to make a new lookup.
No. Same one. In fact, that's a good question. Why don't I just show you that another field in this wrong database. Another field in this database never mind, I'm not going to show you because I'd have to reopen the database. But another field was jaundice, and jaundice used the same yes-no table, the lookup table. You could also just use it as a value list with no equaling 0 and yes equaling 1. That works too. Okay. So back to the PowerPoint presentation. So now we're going to talk about blobs, which stands for binary large objects. The point here is that you've learned about text data types, date types, and number types. But you can also put binary large objects, big files, into a field in a database. And you can either put it in the field, which is called embedding it, or you can put a link to it in the field. And when you store a large binary object, which is basically a file, in a database, you also store with it a pointer to the application that runs that file. So you can do that with a little film strip. You can do it with a Word document. And the most common thing that you can do it with is a photograph. So that's what I'm going to demonstrate now. So I'm now going to go into our student database. And this database doesn't have any of your scores in it. So this is a version of the student database before we started putting your assignment results in it. So I won't be, violating HIPAA by giving students' results